Hello, and thanks for clicking on this next Pre-Narculus production. Today, we're going to talk about how to graph polynomial functions. So we're going to take some of the things that we learned in the last lesson with power functions, such as end behavior and the leading coefficient test, and apply that to be able to graph any polynomial, all right? Not necessarily one that we're going to use transformations for. Okay, so let's get started with some things that we already know, may remember, and things that we definitely know how to do algebraically. So we're going to talk here about zeros of polynomials. We're going to try to find the zeros of a polynomial because those are great points to put on a graph. Okay, the first thing you need to know is that a polynomial of degree n, so a polynomial with any degree, whatever it is, can have at most n real zeros. So for example, if I gave you y equals x to the fourth plus 3x squared minus 5, that's a polynomial with degree 4. Remember, degree is the largest variable exponent. There it is. So it can have at most 4 real zeros. So meaning it could have at most 4 x-intercepts on that graph. All right. And then again, we're going to talk about how to find those in a couple minutes. If I had y equals 5x to the ninth minus 3x plus 2, that's degree 9, which means that this graph could have at most 9 real zeros, 9 x-intercepts at the most. It could have less than that because some of them could be complex numbers, which you learned about in Algebra 2, but at most it can have 9 real zeros, 9 x-intercepts. Okay, so that's the first thing that we're going to talk about here. All right, now the next thing we're going to do is recall how to find zeros of polynomials. Okay, so basically, remember, all you do is you take f of x, set it equal to 0, make y 0, and solve for x to find those zeros or x-intercepts. All right, so let's do it here real quick. F of x equals x squared minus 9. Take 0, put it in for f of x. We can either solve this with square roots or we could factor it with difference of two squares. Either way will work. And then we split them. We have 0 equals x minus 3. 0 equals x plus 3. We get x equals negative 3. We get x equals 3. So this has two zeros. These are the zeros right here. X equals 3, x equals negative 3. There are two zeros, and this is degree 2. So it had as many x-intercepts as it possibly could, this function did. All right, let's try g of x equals 3x to the fifth plus 3x to the third minus 18x. All right, so the first thing we're going to do is set it equal to 0. We're going to try to solve this thing. And hopefully you remember that when you look at this, set it equal to 0, the first thing you should think of is factor it. So let's factor the GCF, take out 3x. We're left with x to the fourth plus x squared minus 6. Okay, so far so good. Now we have 0 equals 3x times, now this will factor as well, x to the fourth plus x squared minus 6. It's a higher order 1am factoring. It's still 1am, but it doesn't factor with x and x. Instead, it factors with x squared and x squared. So we have to find the numbers that multiply to be negative 6 and add up to 1. So that's 3 and negative 2. That's it. Plus 3 minus 2. Okay, so far so good. So now all three of these, none of these really factor anymore, at least easily. So now we're going to set them all equal to 0. We have 0 equals 3x. We have 0 equals x squared plus 3. And we have 0 equals x squared minus 2. So the first one we can solve really easy. We get 0. The second one we can solve, subtract 3 on both sides. Negative 3 equals x squared, but you can't take the square root of a negative number. So this gives you no real solution. No real solution. And then here we can add 2. Take the square root on both sides. Put a plus or minus because we took the square root. So we get x equals plus or minus square root 2. So we end up with 1, 2, 3 x-intercepts, 0, positive square root 2, negative square root 2. Those are our 3 real zeros. Okay, there are two complex zeros here, but we're not worried about those because we're going to try to graph the actual function. So we could have had 5 zeros in total. Instead, we only have 3. That's fine. All right. You can have less than 5, but you can't have more than 5. Okay. All right. So those are your zeros. That's how we find zeros. Don't forget. Okay. So now we can also write a polynomial function. So in the previous slide, you could see that a polynomial's zeros can be found by finding the factors of that polynomial. So if we know the zeros, we also know the factors of the polynomial, right? If x equals a is a 0, then x minus a is a factor of the polynomial. Just think about it. Think about the first one that we just did a minute ago. F of x equals x squared minus 9. Set it equal to 0. We factored it, difference of two squares. We set them both equal to 0 and solve them. 0 equals x minus 3. 0 equals x plus 3. The second one gave us x equals negative 3. The first one gave us x equals 3. Okay, so if x equals 3 is a 0, then x minus 3 must have been the factor that gave me 3 as an answer. When x equals negative 3 is a 0, then x plus 3 must have been the thing that I set equal to 0 to get negative 3. All right, but if you can take the zeros and make them factors, then you can actually write a polynomial. So for example, if I want you to write a polynomial in standard form that has these 3 zeros, x equals 0, x equals negative 3, and x equals 5, then we know that this polynomial f of x must look like this. X minus 0, or x, x equals negative 3. That means x plus 3 must have been the factor. And if x equals 5 is the 0, then x minus 5 must have been the factor, right? Because if I set them all equal to 0, it gives me these 3 answers. So that would be x times x plus 3 times x minus 5. Okay, so now we're going to multiply this out. We have to multiply it. It doesn't matter what order you multiply. I'm actually going to multiply the last 2 first, and then I'll multiply everything that I have by x. So if I do that, I'm leaving the x out of it. I get x squared minus 5x plus 3x minus 15. So I'll combine the like terms, still leaving the x out. X squared minus 2x minus 15. And now I distribute the x to all 3. And f of x equals x cubed minus 2x squared minus 15x. And that is the polynomial that has these 3 given zeros. Again, do you want to check it? If you do, factor this, set it equal to 0, solve it, you should get these 3 answers. If you do, you must have done it right. Okay? All right. Multiplicities and zeros. More stuff about zeros. The multiplicity of a 0 is the number of times its factor shows up in the factored form of the polynomial. So for example, if I had a polynomial, let's say f of x equals, let's say one that's in factored form. So we'll say x squared times x plus 5 times x minus 3. Okay, and I said, okay, let's set it equal to 0 and solve it. You could do that, would not be a problem. Set it equal to 0, split them all up. 0 equals x plus 5, 0 equals x minus 3. Here we get 3, here we get negative 5, here we get 0. So now their multiplicities is how many times that factor was there. So the 0 has a multiplicity of 2 because x squared means x times x, which means it showed up twice. X equals negative 5 has a multiplicity of 1. There's only one x plus 5 in this equation. The x equals 3 has a multiplicity of 1 as well. There's only x minus 3 in that equation. So if I did this, let's say I had x plus 4 to the 5th times x minus 3 to the 7th times x plus 2, then I can figure out the zeros pretty quick. right? X plus 4 would have to be 0. X minus 3 would have to be 0. X plus 2 would have to be 0. So my zeros are negative 4, 3, and negative 2. And let's see what we have here. The multiplicities. Negative 4 has a multiplicity of 5. X plus 4 shows up 5 times. Okay, so that means if I set all the x plus 4 is equal to 0, I'd get negative 4 as an answer 5 different times. X equals 3 has a multiplicity of 7. Shows up 7 times. And x equals negative 2 has a multiplicity of 1. It only shows up 1 time. Okay? So that's a multiplicity of a 0. All right, so now let's find the zeros and the multiplicities. Here we go. Let's set this to 0. And then we're going to split them all up. 0 equals x. 0 equals x minus 4 to the third. And then x plus 1 squared equals 0. So really, I just need to make x plus 1 equal to 0. The squared isn't going to do anything. Here we need x minus 4 equal to 0. We get 4. And then here x equals 0. So here are my zeros. Let's line them up. X equals 0. X equals 4. X equals negative 1. Their multiplicities. 0. It's a multiplicity of 1. The 4 is a multiplicity of 3. And the negative 1 is a multiplicity of 2. So there they are. Now, g is not factored. So we're going to have to factor this one first. This should be 18x squared plus 27x. Okay, let's factor it first. We can take out a 3x. That's in common in all of them. We have x squared minus 6x plus 9. Okay, so now let's factor x squared minus 6x plus 9. It's a 1AMer. So we got to find two numbers that multiply to be 9 and add up to negative 6. So negative 3 and negative 3. So that's x minus 3 times x minus 3. Or we could write 0 equals 3x times x minus 3 squared. That's going to be important for our multiplicities. Let's split them up. 0 equals x or 3x, and then we have x minus 3 squared equals 0. So really just x minus 3 equals 0. So that's 3. Here I divide by 3, and I get 0. So my zeros here are 0 and 3. 0 has a multiplicity of 1. I don't care that there's a 3 in front as a leading coefficient. I care about the exponent of the x. It's a 1, so it has a multiplicity of 1. And the 3 has a multiplicity of 2. Okay? All right. That's zeros and their multiplicities. Now, let's talk about how zeros and multiplicities can help us to form a graph. If a 0 has an odd multiplicity, the graph will cross the x-axis at the 0. So the graph at the 0 will look like this, or it would look like that. It'll literally cross over. If a 0 has an even multiplicity, the graph will bounce off the x-axis at 0. So if here's my 0, it bounces off and comes back. Or if it's underneath, it bounces off and it comes back. Okay? Turning points are the maximum number of turning points. That's relative mins and relative maxes. We've talked about that. Combined is 1 less than the degree of the polynomial. That's the maximum number. It doesn't have to be that many, but it's the maximum number you can have. We're also going to ask you to find how many turning points the thing could have. Okay? All right, so now let's go ahead and make a graph. Here we go. Let's sketch the graph of f of x equals x to the 4th minus 9x squared. All right, the first thing we're going to do is we are going to identify the degree. The degree of this polynomial is 4 because the degree will help us to determine the end behavior. So the degree is 4. Its end behavior for something degree 4, it's even. So normally that's up, up. The leading coefficient is positive, right? There's a 1 in front of here. So it's positive. So that means my end behavior will stay up, up. So my end behavior is up, up. When x goes to negative infinity, f of x goes to positive infinity. When x goes to positive infinity, f of x moves to positive infinity. Okay? Go to the left, you go up. Go to the right, you go up. All right. Next thing, we're going to find the zeros. Okay. Actually, before that, the maximum number of turning points, we might as well write it down. Maximum number of turning points that we can have is the degree minus 1. So 3 is the maximum number of mins and maxes we can have on this graph. Okay, let's find the zeros. The zeros, we're going to take 0 for f of x. We're going to find the x-intercepts. All right. Find your GCF. We're going to factor it. Take out x squared. We have x squared minus 9. And then we are going to factor x squared minus 9. It's the difference of two squares, x minus 3x plus 3. Split them all off. 0 equals x squared. We have x minus 3 equals 0. X plus 3 equals 0. So this one is negative 3. This 0 is 3. And this 0 is 0. Now, there are multiplicities. 0 has a multiplicity of 2. There it is. And the 3 came from here, has a multiplicity of 1. There's a 1 up there. And then x plus 3 also has a multiplicity of 1. Okay. Now, the multiplicity here is even, which means that x equals 0, the graph will cross the x-axis. The graph will bounce on the x-axis, not cross it. It's even. Okay, bounce off the x-axis and come back the way it came from. At x equals 3, it will cross over the x-axis. At x equals negative 3, it'll also cross over the x-axis. Okay, so now, here's how we're going to graph this. We're going to put our zeros on there. 0 is a 0. 3 is a 0. Remember, these are x-intercepts. And negative 3 is a 0. I'm also going to write down at 0, it's going to bounce. I'm going to put a little b here so that I know to bounce it off of there. At 3, it's going to cross. I'll put a c there. And at negative 3, I'm going to put a c there to tell it it's going to cross. My end behavior is up, up. So it's up on this side, up on this side. All right, now, these are sketches. They're sketches. They're not the actual graph. They're just sketches of the graph. Okay, polynomials are continuous, so you can't lift up your pencil when you're going to graph it. So we're going to start up here. We're going to come down. We're going to cross over at this 0. Now, at some point, this graph is going to have to bottom out because it's got to come back up to reach this 0, but it's going to bounce off of it. So it bounces off of it, stays on the same side, comes back down, has to come back up to get to this 0 at 3, and then there's no more zeros, and this is the end behavior to go up, and there's my picture. I get a W, and this is the correct answer. Again, these points here are not exact. Okay, they're just a sketch, but it puts you in the right path as to where the graph actually belongs. Okay, all right, let's try one more. Graph of g of x is negative 4x cubed plus 4x squared minus 15x. Okay, first thing we're going to do is identify the degree. The degree will help us to determine the end behavior. The degree is 3. The end behavior for a graph of degree 3 is normally down, up. It looks like x cubed. That's down on the left, up on the right. The leading coefficient, however, is a negative. It's negative 4, which means that this is going to be a reflection over the x-axis. So my end behavior is going to flip from down, up to up, down. So my end behavior is going to be up, down. When x approaches negative infinity, as x moves to the left, y moves up to positive infinity. When x goes to positive infinity, moves to the right, my graph moves down toward negative infinity. So there's my end behavior. The number of turning points, max number of turning points. It's degree 3. So if I take 1 away, 2. That's the max number of mins and maxes I can have on this graph. Okay. All right, now let's find the zeros and the multiplicities. So we're going to take g of x, set it equal to 0. Negative 4x cubed plus 4x squared plus 15x. Okay, first thing we're going to do is take out the negative. You can't lead with a negative. So let's take the negative out. And we'll also take an x out. So we have 4x squared minus 4x minus 15. So now, all right, we got a factor 4x squared minus 4x minus 15. So we could do that with AC. We could do it with slide and divide, however you want to do it, guess and check. My two numbers would have to multiply to be negative 60 and add up to negative 4. So that would be negative 10 and 6. Negative 10 and 6. Those would be my two numbers if I do it with AC. So I'm just going to factor it here, and I'll bring down this negative x to the bottom line. So I'll factor up here. So I have 4x squared minus 10x plus 6x minus 15. Group the first two, group the last two. Take out 2x. It's in common. You can do this with slide and divide or guess and check or AC. Any one of the three are fine as long as you can do it. Plus, take the 3 out of there, 2x minus 5. So this factors as negative x, 2x minus 5 times 2x plus 3. Now I'm going to split all these up. I get 0 from the negative x. 2x minus 5, 2x minus 5 equals 0. Means x equals 5 over 2. And then 2x plus 3 equals 0 gives me x equals negative 3 over 2. Their multiplicities, each one of them is 1, right? Each one of their factors only show up one time. So it's going to cross there, it's going to cross there, it's going to cross there. Okay, so we got 0, 0. 0 is 1 on the x-axis. We have 5 over 2, 2.5. And then negative 3 over 2, negative 1.5. So it's going to cross here, it's going to cross here, it's going to cross there. My end behavior is up, down. So it's up on the left, down on the right. So I'm going to start up here. I'm going to come down through this 0. I'm going to cross over. I'm going to reach the bottom, but then I have to go through this 0 here. I'm going to cross again. I'm going to come up. I'm going to reach a max because I have to go back through this 0 again. Cross over, and that's my end behavior there. Down on the right-hand side. And that's your correct answer. Okay, and there's your graph. That's how you graph polynomial functions. All right, and as always, thanks for clicking.